Hi, everyone. Welcome to the Warp Space Program Landing Party. Glad you guys could join us. We're here, as you are, as many people across the world are, to watch Perseverance as the rover approaches the red planet. It's really exciting. It's been a couple busy weeks for Mars. A lot of rovers coming. This is the final one from NASA. Before we get started and we talk, just a quick introduction about us. This is the Warp Space Program. We are part of the Warp Institute. We're a group of people who deliver fact-based, optimistic news. And our mantra is that we want to make the future come sooner. You can read more about us at warpspaceprogram.org. Sign up and follow us on our newsletter. And hopefully we'll be doing more of these live streams talking about space. Of course, everything that has to do with space, everything from AI, how it supports life on Earth, these types of missions here, you name it. We're a big group of people. There's a lot of us. We're all volunteers. And with us today are my dear colleagues, Sakke and Cornelia. How are you guys doing this evening?
I'm very fine, thank you. I'm very excited, I must say.
Yes, definitely.
Yes.
It's a great evening. It's a lot of excitement boiling down to this moment when we're seeing Perseverance land. I was just talking to a colleague the other day who had put the calendar reminder for the 18th of February on the very day when the Mars 2020 mission launched back in July to remind her that today at this hour is the landing. So a lot of excitement is boiling down to this moment. And of course, it's happy to be witnessing it also in this format now with the Warp Space Program and live broadcasting.
Definitely.
Yeah. Very, very, very exciting. The three of us, my name, as you can see, is Jakob. I was the editor and manager of the Warp Space Program on my free time. And Cornelia, why don't you start and give us a quick introduction about you and what do you do?
Absolutely. So I'm a part of Warp as well. So I'm writing about space, which I find very interesting, of course. And also I'm studying to my bachelor in physics in Uppsala. So yeah.
Great. And also with us is our logo expert, Sakke. Nice to see you again.
Nice to see you again, Jakob. So yes, Sakke is the name. I'm also part of Warp, and I've been writing news articles on the Warp News website since the beginning of summer last year. I'm also working professionally in the space field with CubeSats. And yeah, like I said before, very excited for this launch. Together with Jakob, we actually made, and with the Warp Space Program group as a whole, we made a top list last year of the top 2020 space breakthroughs, space achievements of the full year, with different categories where, of course, also missions to the red planet were included. And we ranked the Mars 2020 mission and also the other missions to Mars, Tianwen-1 from China and Al-Amal or Hope from the United Arab Emirates, quite high there, didn't we, Jakob?
Yeah, absolutely. I mean, it's fascinating to have three rovers and three missions arriving in Mars at the same time. You would think, but then when you actually look at it, it does make a lot of sense because there is a small window, which is the optimal time if you are going to send a rover or a probe or whatever to Mars.
Yes, exactly. Indeed, it is. It's 2 years approximately that you have to wait between the different launch opportunities, since that's how seldomly the planets are so close to each other that it is beneficial and cost-effective to send probes like this and missions like this from Earth to Mars. So summer 2020 was the previous one, and the next launch window of the same kind will come in November 2022, when we will have a mission going to Mars.
Yeah, so we can expect to have these landing parties will just maybe grow exponentially, and for the coming cycles now, there will be every 2 years or so, there will be a horde of probes arriving at Mars, perhaps. I mean, I think it's, like you mentioned before, the fact that we have other nations like the United Arab Emirates that arrived there, and now we have one from China as well. I mean, it's amazing. There's going to be lots of traffic going to Mars. So I hope that these landing parties, as we're calling them, are going to be more and more common. This is my first one doing with other people online, which is fun. You guys ever done a landing party? Cornelia, have you done one before?
No, this is the first one, but I watch some. So I think it's fun, and like that people also can ask questions that we can discuss and stuff. So it's exciting to see to actually be watching the landing with other people.
Yeah. Oh. And it's great to see so many people that are excited and interested in it. And as Cornelia said, there are comments, so we are keeping an eye on them. So if you do have any questions, please feel free to write them in the comment section. So what landing party? I mean, we all know that NASA is sending a huge TV program live. So basically, we're going to be keeping an eye on that. And we're going to be talking about everything that's going on now until the estimated time of arrival, which is for us, because we're all based in Sweden, actually. So Central European time is in about 30 minutes, or a little less than 30 minutes. So that's going to be really exciting. So until then, we're going to be talking about Perseverance, the rovers, keeping an eye on the live stream. And then we'll follow the 7 minutes of terror, as they're so called, when the rover makes its entry, descent, and landing, and all the work that has been done is, in the hands of fate. So that's going to be exciting. So, but yeah, let's go into Perseverance. Very, very cool rover. Very different from Curiosity,
Well, indeed, also in many ways looking a bit like Curiosity, since a lot of parts on those two rovers are of the same kind, some of them even being the same, ordered in multiple batches back in the days when Curiosity was made. So, but of course, Perseverance comes with many, many different science payloads on it. It comes with many different new types of sensors, looking for habitability and so-called biosignatures are the main missions of this rover, and it's all about then searching for signs of ancient life on Mars to prove, so to speak, that the planet has been habitable once in its history.
Which we're pretty convinced. We think it has been.
Yes.
Right?
True.
If we're going to bet, then we're going to bet that it will find. It might be a long time to search, though. It's, of course, a very big challenge when going out there to another world and searching for small signs of life, or at least what is expected is that the traces of, these biosignatures, that they will really be microbial in nature. So it's very small things to look for there.
Yeah, so I actually got a question from Matthias Sundin. What do you think? When do you think humans will set foot on Mars? So maybe it will be habitable in the future, right? When do you guys think?
Well, if you listen to our entrepreneurial madman, Mr. Elon Musk, he was saying first 2024 with crewed mission. Now he thinks 2026. But Starship is a great project that they're running with. So we'll see. But you can't say anything other than by 2030 we will have humans on Mars one way or the other. Or I would bet that for sure.
I hope so. At least it must be before the 30s. Like.
Then the key question is, would you go?
That's true.
Would you go?
If you get the opportunity, you kind of have to go, right?
Maybe. They talked a lot about that it's a one-way trip. But we also, speaking of what Sakke was saying, that your friend who marked in the calendar, because the trip is 7 months it's taken Perseverance to get there. So it's a 7 month trip there, and then realistically you're there for a year, and then 7 months back. But no, I mean, I'm with you. Opportunity to go to Mars, I don't think it'd be hard to say no. Luckily, my wife's not here because she'd be very upset if she heard me say that.
And wasn't it so that Elon Musk also had this vision? Well, I mean, Jakob, you spoke about exponential growth before when we talked about Mars traffic. And if I remember correctly, there was also a vision some time ago for a really huge city already in Mars in the 2050s. So, you know, maybe starting this decade to send the first human there, let's say in 2030, for example, and already aiming for quite a substantial settlement in additional 25 years after that.
Yeah,
that's of course a very nice vision, and I think that it's that this kind of optimism is what keeps people trying. It keeps people aiming for these Mars missions and to be able to actually send humans there in the near future.
Absolutely, and I'm a big fan. If you haven't seen it, there's a series about Mars that is a mix between interviews with people who are really working to get people to Mars and a show showing, you know, what it would be like, and everything from, you know, I mean, there's so much more than just sending people to Mars. There's the obviously the commercial aspect, the financial aspect. Who's going to pay for this? Why are we spending money on this when, you know, there's a lot of work to be done right here where we are? But then if we do, you know, what are the governing laws and regulations when we get there? You know, how do we ensure that Mars doesn't turn into a wild, wild west? And there are people who are actually working on this, who are you know, spending time making sure that this doesn't happen, which is fascinating. And I think that's going to be, for me, it's going to be really exciting. Someone who is not like you, Cornelia, in physics, or you, Sakke, working with this, who does marketing. You know, I just wait for the first, you know, astronaut needed for communications. I don't know when that would be. It's probably going to take a while, but you know, we're starting to see how no matter what profession you have, hopefully in the future, you could also do that in space.
Yeah, definitely. And if you expand that thinking even more to the legal domain, I mean, here on Earth, you sometimes have law cases between countries, like one country sues another one for certain things. And it will, of course, be interesting to consider whether a Martian settlement would be able to have a lawsuit against another country, or the other way around. I mean, how this would be handled by legislation and policy system that we have today, like how to consider a Martian settlement in the context of international law or interplanetary law, which it would have to be renamed in that case.
It will be a challenge, to say the least, but I think we will be able to fix it. We actually got a physics question, so I'm kind of excited about this one. So Rich Buller writes that 6 missions all launched last July. That was because it took significantly less time with the orbital pattern. Do you have a good answer, Sakke?
Yes, exactly. That is the answer in itself. It's because it takes less time to go once per roughly 2 years. So when Earth and Mars are close to each other in relative terms, and then they are further away again until the next launch window comes. So in July last year, the planets were close enough to make this journey affordable.
But Cornelia, I've been wondering, since you study at Uppsala, you're studying physics, do you hear that a lot of people who are in the science area are talking about space-related careers in terms of physics or engineering or whatever it might be? Because I don't think nobody I knew when growing up who went into those fields were, yes, I want to be an engineer, but there was no one said I wanted, you know, to work on building rovers, or I want to do physics, but no one said I want to be an astrophysicist. Are you seeing that a lot of people are kind of heading in this direction?
Actually, yes, but maybe I'm a bit biased because like many of my friends are like interested in the same area. So of course, like now when I'm studying in Uppsala, many of my friends want to study either space engineering or, for example, astrophysics, because we take like physics first, and then you can go in the direction you feel most interested in. But genuinely, I think that many people are interested in space today. Like it's a growing interest again, and like even my friends that aren't like considering careers are very interested in what happens. Like for example, this Mars landing. Like all my friends knew about it, even ones that aren't especially interested in space. So I think it's a growing interest, and I also think like space creates a lot of optimism with adventures going and so on. So I hope at least.
Are you studying astrophysics?
Right now, I'm basically just studying physics, but I'm taking my first course in astrophysics this spring. So quite excited.
Super exciting.
I actually, when I was in or doing my engineering at the university, we actually, with a group of students, wanted to make and started to make a rover, but the course in which this was incorporated was relatively short, so we ran out of time with actually making it a cool rover. But we at least created the frame, the mechanical frame, a very simple one. But definitely there is the interest already when going into these studies to build rovers, study stars, and aim high.
See, you are a level above me. I was super impressed or inspired by these the helium balloons that were quite popular about 5, 6, 7 years ago, where private people were sending up a picture, or someone sent up a beer can, and it was very simple. And it actually wasn't that expensive or that hard to do. So I was very close to ordering and trying to send up my own latex balloon and see if I could come up to the stratosphere, and then before it popped, and film it and have it come down. That was as far as I got, and only got to an idea. I actually never built one. So I think you guys are way ahead of me. But going back to the rover, I mean, one of the very cool things about, well, there's many cool things about Perseverance that I'm super excited about. One thing is, as I understand it, this is going to be the first time we actually get to see some footage of the actual entry, descent, and landing, which should be amazing, because the other times you watch these, it's a control room, as we were just showing here on the live stream, and everyone's holding their breath and you can't see anything. But now we should actually see everything from the parachute to the heat shield to the sky cables, because I mean the entry in itself, the way they do this is just mind-boggling. I think we have a little picture here showing it. Yes, here you can see. No, here. I mean, the steps they take for landing is just incredible.
And it's of course planned into the most tiny detail as well. So it's there's a really big effort and a lot of teams here on Earth to monitor this and make sure that all goes well. And it's always also a little bit of calculation effort to make sure that you are able to land one of these in the controlled pattern.
I mean, from a physics perspective, this is a big task, right?
Definitely. I would say it's a bit scary because you have so many variables you need to control, but it's definitely doable, of course. and it's very it's amazing how you can plan this in beforehand and actually land, and also now film it on another planet. I really think that's amazing, and the fact that we also are going to go back and get samples, that is very exciting, because then we can, for the first time ever, truly examine Martian soil.
Indeed, yes. So one of the missions for the scientific things that the instruments of Perseverance will do is also sample collection, and then later on, future missions will be able to transport samples back to Earth for future studies. And this is particularly interesting due to the landing site that has been chosen. So Jezero crater is really the ideal place, or was chosen at least among several candidates as the one ideal place to land Perseverance, specifically for the sake of the perceived high likelihood of this place to yield these biosignature samples to be able to find traces of ancient alien life.
Yeah, and I mean, you can't other than assume that this is going to work, because the idea is that they presume that this is a delta. And looking here, we're looking right now at the landing space, and here, clearly what we're seeing, it could be something else, but I mean, it looks very much like a past foreign historic river that has been here, a delta, i.e. water. And as we know, water is considered, if there's water, there is life. And
Exactly.
So this is super exciting. This is where it's going to be, and it's going to be digging. But it also has a very, very cool little friend that it's bringing along. Its little ingenuity. It's Mars copter. What do you guys think about that? The Mars copter. Do you guys see? We have a little video here we can share.
It's really the first time when anyone is trying to make a flight attempt on Mars. So it's really exciting to see how it all will turn out, and how well they have calculated made the physics calculation for seeing how well this will actually be able to fly in the atmosphere on Mars, which is very different from the one on Earth. It's much thinner. So it goes a lot of engineering effort to design those propellers that you see, the blades, as it's called, that will actually be able to lift it. So a lot of, the shape, the mass, the material, a lot of thinking has gone into just making sure that it can lift in the atmosphere that it is going to operate in. Then if it succeeds, then of course you will get pictures like the ones you see on the artist's depiction now on the screen on the video being shown. I mean, being able to actually film the rovers from above and the crater from above, and to monitor the terrain from more up close, that's really worth a lot of valuable scientific data, and especially if you from above you're able to see which location would be most attractive for the rover to check out. That would be really, really amazing, and it's a cool engineering feat, of course, in itself, to be able to fly something on Mars. So really excited for this one.
Yeah, no, definitely. I can only see, I see in front of me how many miniature versions of those are going to be available to buy online, that you and your people can fly with their kids at home. I'm sure they already exist. I think I've actually seen, how you can make your own version of Ingenuity, which is great, always to NASA's credit, that they know really how to engage everybody from 7-year-olds to us older generations. It's very, very fascinating stuff. Now, so I'm looking forward to that one as well. And as we understand it, the atmosphere is much, much thinner on Mars. So it's not easy flying either. It's not that we send one of our drones or one of our copters and just lift and fly around, because it's about 1%, as I understand, the atmosphere is about 1% of what we have on Earth. So it's very, very hard to fly. And also it's very dense, because it's mostly carbon dioxide. So those kind of things, I don't even understand how that affects, but I understand that it does. But how to work that out from an engineering perspective is just mind-blowing. Very, very cool.
And also, from a material science point of view, just to be able to make those structures as light as possible to be able to accommodate that. That's also a cool field of physics of its own.
Yeah.
In itself.
So we have the drill. We have the Mars copter. Another thing that Perseverance has is microphones. We're gonna hear for the first time, I believe, on what Mars sounds like. And this is gonna be really interesting, because, and again, this is how complicated doing anything in space is. Because again, since the atmosphere and the air is mostly carbon dioxide, the frequencies are going to be very low, because sound travels through, there needs to be something to help sound travel. So something that would sound high pitch on Earth is apparently going to sound very, very low, at a very low frequency. So when they pick up the sounds, you're going to have to turn up your bass. And this is because of the atmosphere, which is, those things that you have to think about. Like you were saying, Cornelia, the number of factors, or the number of variables, that you have to consider in every little thing, is absolutely astronomical.
And all these science that will be done, or all findings, they will be crucial for future Mars explorations. So I think it's amazing that we learn more and more, and we lay like a better base for actually perhaps colonizing Mars.
Yeah, absolutely. So I'm making sure that we keep tabs a little bit on that. Sorry, go ahead, Sakke.
No, I was just saying, you also mentioned, like you put the emphasis on the atmosphere in Mars being much composed of carbon dioxide, and actually one instrument that also is present on Perseverance is the Mars Oxygen ISRU experiment, in short, MOXIE. And it's the idea with that instrument is to be able to actually produce a small amount of oxygen from the carbon dioxide in the atmosphere to test, the feasibility of oxygen conversion in that way, to see, for example, if scaled up, that could be accommodating future human settlements on Mars, or making fuel for machines on Mars. So that's also a really, really, really interesting science goal of Perseverance, to actually play around with oxygen and the feasibility of producing that from the Martian atmosphere's carbon dioxide. So I'm also personally very much looking forward to this MOXIE operating and getting results from these experiments.
Well, that leads to that. Do you think we'll one day be able to terraform Mars?
That would require quite a substantial upscaling of MOXIE, but maybe. Let's see.
But I mean, it has to be in the vision, in the plan, going there and building cities. But I definitely think people are definitely going to be looking at, can we terraform? There's a lot of discussions about it. It's not clear if we can do it, but I mean, that would be an incredible feat. We'll see. Hopefully, we'll get there. I am also keeping my eyes on the clock, and our comments here. Our good friend Martin, who's also part of our editorial team, has put in the comments that it is soon time for landing. So we're keeping an eye on the NASA live stream that you have here, because according to the plan, it should be any minute now. And then we go into what's called the 7 minutes of terror, because it takes approximately 7 minutes once the probe enters the atmosphere to hit landing. And as we know, there's not much we can do then except cross our fingers, hope that we've done, that the team in NASA and JPL and everybody else has done a great job, and that there's a successful landing, which I'm sure it will be. But it's going to be nerve-wracking. It's going to be very, very exciting.
Yes, and I can also see how in the live stream they are now going into this what's it called, studio, I would say, where they are monitoring also the landing itself from a lot of computer screens. So right now you're able to see how they are looking at data, monitoring telemetry, and checking that everything works fine. So I guess the live stream will soon transition to that room more and more.
Have you guys ever been in a control room?
No, unfortunately not.
Me either. It's definitely high up on my list.
Not for a space
very,
mission.
very cool. But for another mission or something else.
Yeah, I in a little bit of different excursions to different companies and things I went to when I was a student, different control rooms of different kinds of plants, power plants and so on.
I had to say, so they're showing some story about peanuts, which is I'm not aware about the significance of these peanuts, but I guess this is tradition that they open and they feast on peanuts when they have a successful landing. I need to follow up on this because this sounds like a great story. I had no idea about it. Do you guys recognize this?
No, but I saw in the comments that there was at least one person watching this who was prepping for a show with popcorn. So peanuts, popcorn.
That's true.
Think there are those two groups out there. Some people prep for a launch with peanuts and others with popcorn.
Sure. We actually got
there's
some
definitely
more
something we
questions.
missed.
Sorry.
Go ahead.
Do you know
Go
what,
ahead, Cornelia, please. While we wait.
do you know what the rover weighs?
Yeah, according to information that I've read, the rover weighs about 1 metric ton. And again, it's basically the same as Curiosity, and I think we talked about this, or was it before? Which is that when you build the rovers, there's a lot of reserve extra parts, and when they were done with Curiosity, it's so many extra parts, estimated to a value of $200 million still, that they basically just built another rover. But Sakke, you had some insights on why this is, and that this actually isn't that unusual at all.
No, I mean, basically, when you prepare for a mission like Curiosity, you have a lot of consideration, of course, on the parts that go into the mission. And one thing that, especially when you have very expensive and important science missions that you are constructing, you usually buy a lot of spare parts to be able to make sure that if you would somehow have an error or a manufacturing mistake in one of them, you would decrease the risk by having multiple of them procured. And thereby, when Curiosity at some point then became ready, it was launched, then they had spare parts left, and they were able to reuse those parts if they were functional now for the next mission. So this is how they were able to already get a head start in their production by using components and parts that they already were familiar with.
I heard someone reference it, the greatest IKEA put together ever.
And yeah, it's big in size as well. We were just talking about the mass. It weighs 1 metric ton, more or less, and it's also 2 meters long and 2.2 meters high. So it's a really, really big rover there on the Martian surface soon. Right now landing.
It should be, yeah. Unfortunately, since we're here talking to you, I haven't been listening to what's going on in the here, but it should be happening any minute now. And again, I'm very much hoping that we get to see some actual footage of it entering. Now there is a delay, so I guess maybe the 21:43 or the 4 minutes ago estimated time arrival was the actual. Then it takes about 8 minutes for the communication to come back and reach us, since it's so far away. So when we see what we see, that'll actually be in the past, which also is going to complicate things when we have people there on Mars, because it's always going to be a bit of a hassle communicating, because there's going to be such an extreme delay. So if you think your Zoom and team meetings are bad now, just wait until we have people on Mars.
True. We also got a question regarding how big of a risk this landing is. Do you have any thoughts?
See that the people is still on.
I guess that question comes in the sense of what the probability would be for failure. I think that is very hard to say. I do not have those estimates, unfortunately.
Sure. But we're optimistic, though.
It comes down to many different steps and parameters. So there can always be, in one or another occasion, that you probably introduce a slight delay or a measurement error or a coordination error in some system, and then maybe that could propagate into causing an escalation of some sort. But I think that, of course, everyone is hoping that everything will go really well here. So I don't know, actually. But it's these things are things that teams across the globe here have researched and prepared for a long time. So a lot of thinking has gone into what could potentially go wrong, and then they have made sure to solve that beforehand, before entering this stage.
Yes, so I think we should be optimistic, even though, of course, there's a risk.
And they already did land other rovers before, so although it's of course a risk every time you make such a landing, it's for each time you do it, the more you learn and the more you know. So it's a lower risk every time. And now, any minute now, we will see landing itself.
I hope so, right? Because as I said, it is about 8 minutes delay. So, and according it arrived 8 minutes ago. It's going to be very, very exciting. Yeah, I'm starting to get nervous. Cornelia, you shouldn't have asked that question if we thought it would the risks. Now I'm nervous for the people who have been working on this for so many years. But I like also Sakke's confidence, so he calmed me down a bit. But speaking of astronauts, ESA just released that they are looking for astronauts. So, hopefully, maybe the next one will be ESA probe or an ESA rover that gets sent to Mars. Are any of you guys planning on applying for the astronaut positions? I haven't looked at their criteria, but I do know one cool thing is that they are looking for the first person with a physical disability to be sent up to space, which I think is very, very cool.
Definitely.
I haven't had time to look at the criteria either, unfortunately, but I do know that it opens now during the spring, so it's going to be really exciting, of course, to see what the criteria are.
And it's the first time in a decade, so it's been some time since they were recruiting. So I think if you have the requirements, I definitely think you should apply. But I have some more studying to do.
But also, it's very positive that it seems to be the criteria seems to lower each time. More and more, keeping the dream alive that one day a regular person like myself could maybe be able to go into space.
We're getting questions also in the comments about what experiments we're most excited about in this mission. And we already lifted the flight with Ingenuity, of course, the first time that somebody is attempting to fly something on Mars in the Martian atmosphere. And we also had MOXIE, the oxygen experiment, so trying to convert oxygen out of the carbon dioxide in the Martian atmosphere to be able to see if that could then later be scaled up into a facility or a machine that converts oxygen from the atmosphere more to support, for example, a human habitat or some sort of fuel production on the planet. So those two are my personal favorites with this one. But then there are, of course, the search for traces of ancient alien life as well.
And what's frustrating there is obviously that if Perseverance were to find something, we then again need to send another rover or probe there to get the sample and then come back. So as we know, all of this is going to take a long time. But before you know it, it's there. Like you said, you watch the launch, and then perhaps you forget about it, and then all of a sudden it's in your diary that arrival is just around the corner. So, but it's going to take some time. But that's going to be very, very exciting. Sure.
But something that is also really exciting about this mission as a whole is actually that NASA during last year had an initiative called AI for Mars. And that was really about, and now I see some action in the live stream as well, so we should keep a close eye on that. Just quickly, AI for Mars, that was really about having people in general who are interested in helping out this Mars mission to analyze pictures taken from previous rovers and making sure that, basically looking at those pictures and seeing what kind of structures you have there on the Martian soil, in order to then later be able to teach AI algorithms, so artificial intelligence algorithms, about what structure, what the images actually are in reality, what structures in the pictures actually are, in the geology on Mars, and then thereby being able to teach these rovers in the future what they are encountering and be able to do self-driving missions and maneuvers. So that's a lot of people have helped out also for the future of Perseverance rover's career on Mars, just by analyzing images and seeing and typing and defining what's in there. So that's really humanity's space adventure.
Yeah, no, absolutely. So we're keeping an eye here, and I think it's fascinating how interesting it is to see a bunch of people sitting in front of computers in a control room. You know what they're looking at and what they're waiting to hear, and you can feel the tension and the excitement in the room, and perhaps the heart rate of this this woman as well. I can only imagine what they're going through right now.
Probably they're going through a lot of numbers on the screen, and being nervous and trying to follow everything as they come, and keep a track of the latest data and verify at the same time that everything is as it should be, and the rover is on track down.
So we're waiting to see if we get any confirmation, if we get any footage maybe of the lander. We'll keep our fingers crossed. Again, until then, I mean, the landing itself is quite amazing. I remember we talked about it before with the smaller rovers, being Spirit and Opportunity, who are about 200 kilograms, who actually had this bouncing ball landing approach, where they were covered in big air balls and then bounced. And I read somewhere that they estimated that they bounced about 30 times before they came to a stop when they landed. I mean, you can just imagine the kind of force that they hit Mars with. And I can't help but wonder if there was someone there living who then all of a sudden saw this enormous balloon-covered ball just come bouncing in their backyard. It must have been an incredible sight. But it was also, you think about it and you'd say, that's what we're going to spend our money. That's our strategy to cover this ingenuity, this project that we spent all this time and money on with air-filled bubbles and balls. That's how we're going to land. So I understand that, whoever presented that idea must have been very courageous and say, this is going to work. It's the best way forward. But it would have been amazing to be in that room, to hear that pitch, to say, this is how we're going to successfully land on Mars. And it worked. So
it was very innovative, though.
Extremely. So I'm getting notes here from our producers that's saying that it has indeed landed.
That's really, really great.
Now, it has indeed landed. I guess we're getting the first signals. If we get any footage, I'm a little disappointed we didn't see the entry. I was very excited about that. Maybe they'll show it afterwards.
Hopefully.
Maybe we were a bit delayed.
Atmospheric entry. Okay.
So it seems that the stream is maybe behind the wheel, or maybe.
Are we behind in the stream? Yes.
Oh.
Let's see here.
This is things that you can do when a timer is on the screen.
These are the things. Yeah, this would have been very helpful if we've been watching it live. I'm very sorry about that. I thought this was up today. So we've actually been a little bit behind. So everyone who's watching this has probably already known that it's landed. Though we seem to be, I think we're as live as we can be.
Well, Jakob, you will have a chance later this spring again, hopefully. I mean, we have also still ahead of us the landing of the rover of Tianwen-1, which is like the Chinese mission. So the orbiter is already in orbit around Mars. It arrived, or it made the maneuver to be captured by Mars's orbit 1 week ago approximately, but it will be orbiting for a while before it goes to the state of the mission where the lander will go down to the Martian surface. So maybe that will be live streamed, and maybe we will be able to watch that one in real time then.
Hopefully, one day we'll definitely get there and get the visuals. We'll see. I remember when I was watching Curiosity that they waited for a while, and that the first thing Curiosity did was to take a picture. They came back that was covered in dirt basically, so you couldn't see anything. But it was still a picture confirming that it was on the surface. So I'm wondering if they'll do something similar here. But again, according to our friends and people watching this, it has indeed landed. So here we're looking at a little bit more detail.
There should be footage now, according to our comments. So maybe we're a bit behind still. perhaps.
Potentially
They're showing the first images now. I apologize. My YouTube live is lagging behind.
Velocity is about 90.
Oh no, what an anticlimax. We missed the whole thing. Well, there you go. But they did it, which is great.
Yes.
There we have it. First image. Fantastic.
So bring
Very,
out
very
the
cool.
peanuts or the popcorn, because now it's time
Yes,
to
apparently now we all get to celebrate with peanuts. I definitely need to follow up on that story. That's funny. But this is great. Fantastic news. Well done, NASA, JPL, everybody. Thanks everyone for following us. I apologize again that we were a little bit delayed. Yeah, look at that. That image is much better than the one that Curiosity sent back.
They're near the ground.
That's amazing.
Postcard from a Jezero crater.
These cameras, but seconds after landing, so
Fantastic.
to the air from our landing event.
Well, guys, thank you very much for joining me on this landing party. There'll be more to come. This was our first one, so we've definitely learned a lot. I will definitely make sure that the live stream is up to date this time. But overall, fantastic news that Perseverance has landed. Super excited to now see all the science that's going to come back and all the studies they're going to do. Sakke, Cornelia, thank you guys for being here, and thank you all for following us. Stay tuned. We'll do more of these. We are also planning to have a live or a physical meetup on August 28th. And if you can't join, we'll definitely be doing some digital events from there as well. And we're going to invite some exciting people. We're going to talk about space. You can find out more at warpspaceprogram.org. So please remember to go in and follow us, get the newsletter, and you'll see more from us.
What an amazing day.
Stay tuned
Thank you, guys.
about Mars as things happen.